Today's topic is graphing quadratic equations, and in our book that's section 9.3. And our objective today is basically to graph a quadratic equation when we're given it in standard form, which is ax squared plus bx plus c. So again, this is our standard form of quadratics, and we should be familiar with this by now. And so we're going to look at how we graph these in different ways that we can graph. The first thing that we need to look at is we need to go back and we need to remember what a y-intercept is. Now, a y-intercept, as we remember, is where the line that we have crosses the y-axis. So we can see that over on this graph that our y-intercept here is y is when it is equal to 1. Now, the important thing that we need to remember about a y-intercept is not just where it crosses the y, but also too when x is equal to 0. So a y-intercept truly is when x is equal to 0, but it is true that that's where it crosses the y-axis. So this is a little bit different than what we've seen before with linear functions. So when we move to quadratic, we can see it still has a y-intercept. So some things about linear and quadratic are going to be exactly the same. So if we think about this concept of that when x is equal to 0, let's think about what happens when we put 0 into here and 0 into here, and we have something that's y equals this. So what happens then is that these two terms go away, and we're left with y equals c. And so this is y equals 1. So basically what we can tell is that whatever this c value is our y-intercept. So whenever we look at a quadratic equation, if we look at c, whatever that last number is, the number that's the constant, that's always going to be our y-intercept. And that was true with our linear functions. If we had y equals mx plus b, b was our y-intercept, and it was the one that was left by itself. There was no variable or anything like that. So as soon as we see the c here, we should automatically think y-intercept. So in this equation, if we were to say that this equation matched this line over here, what we could say is that c was equal to what? Well, c was equal to 1 because that's where it crosses the y-axis. And now what we're going to talk about is we're going to talk about some steps to graph quadratic functions. Now, keep in mind that we could use a table of values. There's nothing wrong with a table of values, but it doesn't necessarily give us a best description of what this graph will really look like, because when we graph it using a table of values, we're only looking at it from a standpoint of just plain points, and so we could potentially draw the wrong kind of line. So the things that we're going to look at is we're going to find the axis of symmetry, or the line of symmetry. We're going to find the vertex of our quadratic function. We're going to find the y-intercept, which we just kind of looked at, and then what we're going to do is we're just going to create a couple points, and then we're going to reflect them across our line of symmetry, and we'll look to see how those things all work together. Okay, so the first thing that we need to do in order to graph these things is we need to find our axis of symmetry. And if we remember about this line of symmetry, it simply can be found by using the opposite of b over 2a. That's the only thing that we need to do in order to find this line of symmetry. And so if we plug in these values, we get a is equal to, well, that's the first number there, so 3. And then b is equal to negative 6, because if we look at this, this is minus 6x, which is really negative 6x. And so if we plug in these values, we get the following. b equals the opposite of negative 6 over 2 times 3. And so what we end up with is we get negative 6 over negative 6 over 6. And two negatives become positive. 6 divided by 6 is just 1. So our equation for a line is simply x equals 1. And so what we can do is we can just draw a vertical line. We can draw a vertical line starting from x equals 1, which is right here. So we can draw this vertical line down, give it a couple arrows, and that's our line of symmetry. So now that we have a line of symmetry, what we're basically doing is we're taking this and just kind of expanding on it and creating more things. Okay, so now that we have our axis of symmetry in place, now what we can do is we can find the vertex. And the nice thing about this is I told you that the vertex has the form x comma y, and we know that that line of symmetry goes through the vertex, so the x value is going to stay the same, and we already found the x in the last page. We know that that x is equal to 1, and so now all we really have to do now is take that x and plug it in to get a value for y. And so we get y equals 3 times 1 squared minus 6 times 1 plus 1. So that gives us y equals 3 times 1 minus 6 times 1 plus 1. I just took that extra step to show you that 1 squared is always 1. So we get y equals 3 minus 6 plus 1, which is going to end up giving us y equals negative 2. And so after we get this y equals negative 2, we can put this in an ordered pair, and so our ordered pair for our vertex, so our vertex is 1 comma negative 2. And so what we can do is we already know it's going to lie on that line of symmetry, so what we can do is we can come over here and we can just draw a dot at 1, negative 2, where this is our vertex. Okay? Now the other thing that we can point from this is that if we look at our original equation, we can see something about a. What do we notice about a? Well, a is equal to 3, like we said before. Now, is our graph going to point upward or is it going to open downward? Well, we know since a is greater than 0, our graph is going to open upward. So really, we can kind of ignore all this stuff down here because this isn't going to worry about us because our graph isn't going to go down here. So we know that our graph is going to point upward from here on out. And so now we're going to expand on this idea. So now we got two things in place. Now we're going to go to the next step. And that next step is to simply find the y-intercept. Now, I told you before what we can do is we can just look for the form ax squared plus bx plus c, and I told you that c was indeed our y-intercept. So in this equation, we have our c, which is 1, so our y-intercept is where y equals 1, and so we can go over to our graph again, and then we can mark the y-intercept of 1, so here, and this is our y-intercept. Now the long way that we could do this is we could say, okay, well, we know that the y-intercept is when x equals 0. So we could plug x in, we could plug 0 in for x, and then we could say y equals 3 times 0, did that backwards, 3 times 0 squared minus 6 times 0 plus 1. These go away, so we get y equals 1. So that's the long way of doing it. And then we have the ordered pair 0 comma 1 because we have x comma y for our ordered pair for our y-intercept. And that's important when we don't understand quite what the y-intercept means. So instead of just placing a dot at y equals 1, what we could also do is we could create our ordered pair so that we could easily graph 0 comma 1. And so now we have two dots in place, but we don't have quite enough information to really get a good idea of what this graph is doing. And so what we need to do is the next step. That next step is to simply just create two extra points. And so the way that we do this is we just choose two random values for x to plug in to get a y value. So we can just say, well, how about x equals negative 1 and x equals negative 2, because what I'm going to do is I'm just going to choose two things on one side, and then what I'm going to do is I'm going to reflect those, because we know that parabolas are symmetrical, and so whatever's on one side is in the exact spot on the other side. And so what we can do is we can just find these values. So y equals 3 times negative 1 squared minus 6 times negative 1 plus 1, and over here we get y equals 3 times negative 2 squared minus 6 times negative 2 plus 1, and we can evaluate these. So we get y equals, this is end up being 3, and this is going to be plus 6 plus 1, because right here, negative 6 times negative 1 is just positive 6. And so in this case, we get y equaling 10. So our ordered pair then is negative 1 comma 10. And then over here, we get y equals 3 times 4, because negative 2 times negative 2 is 4, plus negative 6 times negative 2 ends up giving us positive 12 plus 1. So y equals 3 times 4 is 12, plus 12 more, plus 1 more, gives us y equals 25, which is a little bit off our graph, but that's okay. And so we get the ordered pair, negative 2 comma 25. And so if we adjusted our scale, we could do this, but what we're going to do right now is we have a couple values that we can reflect. So the first thing that we can reflect is, we know reflection is basically just the same amount of distance from one side to the other. So we can create a reflected point for our y-intercept, which is right here. We can plot this other point of negative 1 comma 10 to be negative 1 here, up 10. And we know that has a reflected point, and that looks to be 2 spaces away from our line of symmetry. So we can just plot another point in the same location. Those are exactly reflected from each other. And then what we do is we just draw a smooth curve through those points, and we're done. And that's it. So we created a couple points to reflect. Now we couldn't use the second point that we made up just because it wasn't on our graph. So we need to be mindful of making the appropriate size graph and then reflecting the appropriate points, or choosing appropriate points to plot so that we can get some reflection. And so before we finish, we're just going to do one quick example. So the first thing that we need to do is we need to find our line of symmetry. So we use x is equal to negative b over 2a, which is negative, our b is 6 over 2 times 2, which that ends up equaling negative 6 over 4, which is negative 3 over 2, or negative 1.5, or 1 1/2. Second thing we need to do is we need to find our vertex. So we plug that value back in, and so we get y equals 2 times negative 1.5 squared plus 6 times negative 1.5 plus 2. And then we get y equals, that equals 4.5 plus negative 9 plus 2. And so we get y is equal to negative 2.5. And so our ordered pair for our vertex is a grueling negative 1.5 comma negative 2.5. The third thing that we need to do is we need to find our y-intercept, and our y-intercept is y equals 2, because we know c equals 2, and so those two things will be the same. And then we just need to create a couple points in order to do this. And so the first thing that we're going to do is we're going to plot these other points first. So we know that our axis of symmetry is going to go through negative 1.5, which is going to be a little bit tricky to graph here. That's okay. So our axis is right there. We know this is facing upward because 2 is positive, and that's A. The next thing is we plot our vertex, which is negative 1.5, negative 2.5, which is right about here. And then we plot our y-intercept, which is y equals 2, which is right here. Now, the first thing that we could do is we could say, okay, well, I can plot this point right here because that's the same distance away. This is my y-intercept here, so y dot I, which is y-intercept. I can reflect that point here. Remember, this is my vertex. Then I could probably just choose one other point. And so I'm going to choose, let's see, On my graph, I'm going to choose this point right here for my x value, which is negative 1, 2, 3, 4. So I'm going to choose negative 4. So I get y equals 2 times negative 4 squared plus 6 times negative 4 plus 2. When I do this, I get 32 because negative 4 squared is 16 times 2 is 32 plus negative 24 plus 2, and so I get y is equal to a positive 10. 32 plus 2 is 34, minus 24 gives us 10, and so if I plot these 2 points, I can plot these as negative 4, comma 10, which is here, and then if I reflect that, I get the same thing, so that's 1, 2.5 spaces, that's a half, 1, 2, so my reflected is there, and those look about to be the same distance away from each other. And then what I can do is I can finally run my line through here. Nice smooth curve, as symmetric as I can make it, and then that's it. So find the line of symmetry, find the vertex, find the y-intercept, and then create a couple points to reflect that are on the graph, and then basically connect them with a nice smooth curve. So you might be asking yourself a question, okay, well what happens when I'm given an equation that looks like this, so it's not the way that I need it? So basically what we do with something like this is just put it in standard form. So if it's not in standard form, put it in standard form and work everything from standard form. And so basically just something to remember, that you could create a table of values if you really wanted to, but it's really not the best use of your time. If you can easily find your line of symmetry, you can easily find your vertex, you can easily find an ordered pair that's on the graph, you can easily find your y-intercept. So right there you already have a collection of points at your disposal that you don't really need to work very hard for, and you don't need to plug in these numbers, you substitute them and then solve it. So what you can do is you can just do 1 or 2 points, then you have enough points to plot it and then graph it. And that's it.